Right, our lesson for today is going to be a review of our laws of exponents. So a reminder that when we're dealing with powers, when we're multiplying powers, dividing powers, raising powers to other powers, there's lots of rules, and we call those our laws of exponents. Okay, so this beginning table of our notes is going to just go through our different rules, and we'll kind of go from there. So our first rule, the multiplication of exponents. Let's actually talk about this example to the right first, and then that'll help us get to our general rule. Okay, so it says a squared times a to the third. This just goes back to what an exponent is. Okay, so remember, an exponent is a way to rewrite multiplication. So for example, a squared, that's the same thing as saying a times a. Well, a to the third, that's the same thing as saying a times a times a. Well, now if we look, we're really multiplying together 5 different a's. Okay, so what this would turn into is a to the fifth power. Well, what do we do with our exponents then? Well, 2 plus 3 would give us 5. So in this case, our general rule, if we had b to the m times b to the n, that would be b to the m plus n. Notice it's still b, right? It's not b times b where it turned into like a b squared, right? So if those were 3's and it was 3 squared times 3 to the third, it would not become 9 to the fifth, right? It would be 3 to the fifth. We're repeating that base. The base stays the same. Okay? Power raised to a power. So we have an example here, a squared raised to the third. Well, again, this exponent on the outside of 3 is telling you how many times you're repeating your base. Well, in this case, our base is a squared, since all that's in parentheses. This is the same thing as saying a squared times a squared times a squared. Well, using the same logic of above, if we added all those exponents, our answer would be a to the sixth. Now we think about what did we do? We had a squared raised to the third, and it became a to the sixth. Well, really what we did was we multiplied. Okay, so this example over here, that would be b to the m times n. Okay, the power raised to a power, we multiply the exponents. Okay. This example here, it says in parentheses bc to the n. Well, remember in this case, since all of b and c together being multiplied is inside parentheses, that's acting as your base. So now this n needs to go to both parts here. So it would be b to the n power times c to the n power. Okay, since each of those variables inside the parentheses together were acting as the base. Okay, division of exponents. Okay, so let's again try to get to what a general rule would be. Okay, so like if we had a to the fifth divided by a squared, that's really saying we have 5 a's on top. We have 2 a's on bottom. Well, if we were going to simplify that, we could cancel 2 pairs of these a's. Well, what are we left with then? Well, we have 3 a's left on top, a to the third. So our general rule, well, we had a to the fifth divided by a squared, became a to the third. What did we do? Well, we subtracted those exponents. Okay, so our rule here, we'd say b to the m minus n power. Okay. So those are our 3 main rules. Now these are kind of some properties that we have to remember. Okay, so first the exponent of 0, b to the 0 power, any base that's raised to the power 0 is actually going to just equal 1. Okay. For example, to the right, 3a squared, all in parentheses raised to the 0 power, not going to be 3, it would be 1. The whole thing is that exponent of 0. Negative exponents. Okay, so we have a special rule with negative exponents. Typically in math, we don't express answers with negative exponents. We express all answers with positive exponents. So we have to know how to rewrite a negative exponent into a positive exponent. The way we do is we actually flip the flip it from the numerator to the denominator, or if the negative exponent is in the denominator, it's going to come up to the numerator. Okay, so for example, b to the negative n power, if we were going to rewrite that as a positive exponent, it'd be 1 over b to the n. Notice the negative exponent changed to a positive. Versus if our negative exponent is in the denominator, then it's going to flip up to the top. So this would actually just be to the n. Okay, so like if it just said 3 to the negative second power, we could rewrite that as 1 over 3 squared. And then 3 squared on the bottom is 9, so 1 over 9. All right, let's do some example problems, just kind of a mixed review. Okay, so x squared times x to the fourth. We're multiplying two powers. Remember, our rule is to add the exponents. X to the sixth. Versus the difference between that and number 2, this is x squared raised to the fourth power. So remember, now we have a power raised to a power, so we'd multiply our exponents. 4 x to the eighth. Okay. More mixed review examples. 3 x, y in parentheses raised to the third. Remember, since this exponent on the outside goes to everything inside our parentheses, this would really become x to the third, y to the third. Notice there's nothing else we can do there, right? If we can't just multiply these together and make this like xy to the sixth, right? These are separate powers that are multiplied together. Okay. X to the seventh over x to the fifth. Well, now we're dividing our powers. Remember, we subtract the exponents. So the x squared. Okay. Got some more. Next page. X squared over x to the eighth. Well, we'd subtract them. So this is going to become x to the negative sixth. Remember, we would never leave our answer like that. Okay, so if it's x to the negative sixth, we're going to rewrite that as a positive exponent. That's 1 over x to the positive sixth. X to the 0 power. Well, remember our special rule, anything to the 0 power is 1. 7 x to the negative third power. Because remember, we would just rewrite that as a positive exponent. So 1 over x to the third. Versus 8, 1 over x to the negative fourth. Well, now our negative exponent's in the denominator, so it's got to flip up to the top, to the numerator. So now that's going to come to the top, x to the positive fourth. Last couple. 9, 2y is acting as our base raised to the fourth power. So this exponent needs to go both to the 2 and to the y. So this is the same thing as saying 2 to the fourth power, y to the fourth power. Well, 2 to the fourth, we wouldn't just leave that like that because that's just a number raised to a power, raised to an exponent. So let's simplify that. Well, 2 to the fourth power, that's just 2 times 2 times 2 times 2, which is 16. We have 16 y to the fourth. 10, 3x to the fourth times the parentheses x minus 5. Well, this is really a distributing problem. We multiply the 3x to the fourth to both. So really this is saying 3x to the fourth times x. And then we have 3x to the fourth times negative 5. So that minus sign is going to carry over. So minus 3x to the fourth times 5. We're multiplying them both by that. Well, this x really just has an exponent of a 1 on it. So we would add these together. We have 3x to the fifth minus, well, 3 times 5, 15, x to the fourth. Okay. These are just kind of some simpler laws of exponents problems that we're going to build off of as our starting point. Okay, so we'll kind of build from here and get into some tougher ones.